Hello everybody, welcome to Physics in a Nutshell, and today we're going to learn about quarks. So what are quarks? Quarks are the fundamental building blocks of matter. They're inside you and me. Everything is made of quarks. Quarks were first proposed in 1964 and they were observed in Fermi's lab in 1995, and that's in America. There are 6 flavours of quark, and every quark has an antiquark, and take note of that because you'll need to know that. So the main family is hadrons, and branching down from hadrons are baryons and mesons. Baryons have 3 quarks inside them, mesons have 2 quarks inside them. So we need to know about the names of the quarks. So as I said before, there are 6 different quarks. You have the up quark and its corresponding anti-up quark, a down quark, charm, strange, top, and bottom. I'm going to take away charm, strange, top, and bottom have all decayed away. They're very unstable and they've undergone particle decay. Take note of this. You need to know which are heavier. Top and bottom are the heaviest. They decayed away the first. Up and down did not, and they're still here. So what is the basic maths for quarks? So quarks have intrinsic properties: charge, colour, mass, spin, but we're going to focus on charge. So the charge is either plus 2/3 or minus 1/3. Hadrons, that should be baryons, have 3 quarks, and it must add up to 0 or plus 1. So when you do the maths, it must add up to 0 or plus 1, unless you're doing antiquarks, which is minus 1 or 0. So the up, top, and charm, they have a number of plus 2/3. Down, bottom, and strange, they have a number of minus 1/3. You need to remember this. This is very important. I'm going to give you a question. So a neutron has a quark configuration of up, down, down. What is the charge of the quark? Pause the video and I'll reveal the answer. So the answer is 0, since up, down, down is 2/3 minus 2/3, and that gives you 0. And because you've got 2 downs, minus 1/3 times 2 is minus 2/3. If you got it wrong, pause the video and watch this section again. Question 2. Here is my proton. It has 2 up quarks and a down quark. What is its charge? Pause the video and I will reveal the answer. Okay, so I hope you got plus 1. Up is 2/3, 4/3, 4/3 minus 1/3 is 3/3, which is 1. If you didn't get that, then redo it, look back at my last section. Alright, so what holds quarks together? And it is the strong force. This is quite important because otherwise quarks could just fly away and there'd be no me and you. And why is it so stable? And it's all because the strong force holds it all together. And the exchange particle for this is gluons. Now we need to know a bit about gluons. Gluons are massless exchange particles. They have colour and spin. That's their properties. And here are the gluons in my proton. I hope you noticed them. And these give quarks the colour. So when I said on the slide 2 about the intrinsic properties, you need to know that quarks have colour and the gluons have colour. And now gluons are very weird. They are virtual particles, so they're only real when they are needed to be real. So they'll be real on and off, but they're borrowed, and they're only there for a certain amount of time, and then they have to give up and they disappear. It's a bit harder than what I'm saying, but a simplified version is they disappear, and then when they're needed again, they reappear. And there are the gluons in between. the quark, in between my proton. So as I said before, there's baryons with 3 quarks and mesons. We need to know a bit about mesons. Mesons consist of a quark and an antiquark. And because of quarks and antiquarks, if they're together, they should break off and evaporate, you could say. But no, they are very short-lived because of this. They don't evaporate because that would be silly. And due to them being stuck together, they're obviously going to decay away. It gives you electrons, neutrinos, or photons when they decay away. If it's a charged meson, it gives you a photon. If it's 0, then it's an electron or neutrino. So an example of a meson is a pion. Now there's lots of different names, you just need to remember them, it's quite complicated. So a positive pion is made of 1 up quark and 1 down antiquark. What is the charge of the meson? Pause the video and work it out. Okay, so I hope you got the answer is +1. Now, unless you noticed I give it away there, the problem is if you didn't get it, I'm going to re-look at this, but if you did, this is what you probably did. You realised an up quark has a charge of +2/3, and then you have a down antiquark. Now a down quark is -1/3, so if it's an antiquark it has the opposite, which is +1/3. So +2/3 +1/3 is 1. Okay, so that is it on my basic training on quarks. If you have any questions, leave a comment and I will reply, and I will say thank you for watching, leave a rating and have a good day.